Welcome back. Super excited. Moving forward, in this important lecture, I'm going to talk about in depth about machine learning algorithm, classification, regression, k-means, and so on. So there's several types that we can actually use. I'm going to talk about the advantages, disadvantages, and why you should use any one of these algorithms. So bear with me, about 10 or 12 slides. So it may take a little while, but I want to make sure that I get the concepts across. And when you see everything in action, it becomes very clear. So let's jump right in. So machine learning algorithm, think of this as developing a model, which is like a vending machine, which given an input, in other words, you place or you put money in the vending machine, and it'll give you some output, such as candy bar, chips, or soda can, whatever that is. An algorithm is what is used to train that particular model. All the decisions within that model is supposed to take based on the given input to give an expected output, right? For example, an algorithm will decide based on the dollar value of the money, right? Which is an input, whether it's $1 that you input in the vending machine or 50 cents or whatever it is. So once that dollar value of the money is provided to the vending machine, product you chose, whether the money is enough or not, right? So it's going to decide whether enough money has been input or not based on the product that you select. Let's say you selected a candy bar that is worth $1.50, and here you only input $1, right? So of course the result is going to be negative, right? No, you can't have that candy bar. So whether the money is enough or not, or how much balance you're supposed to get or back, provide additional money, and so on, right? So you get the idea what a model is in machine learning and what an algorithm and how algorithms are used. So in a nutshell, okay, keep this in mind and memorize this. An algorithm is simply a mathematical life force behind a particular model. So whatever it is that you're creating, whatever business problem that you're about to solve, in order to solve that problem, you need to provide certain steps, right, or mathematical steps. Let's talk about the regression algorithm. The regression problems are problems where you simply try to make a prediction on a continuous scale. Data is labeled, right, which is supervised learning, with a real value rather than a label itself. So now you have a real value that you want to work with. For example, you could be predicting the stock price of a company, or you could be predicting the temperature for tomorrow based on historical data. And that's how you get the weather channel, right? So you know exactly what the weather is going to be like in the next week or the next day, right? Obviously, no one can tell the future, but it's pretty accurate, okay? And how it's done is based on previous or historical data. So linear regression is a way we analyze the strength of the relationship between one variable, which is our outcome variable, and one or more other variables are independent variables. So there's a dependent variable and an independent variable. So that's linear. Of course, there's multiple regression as well, where you have multiple variables. The neat part about linear regression, like the name implies, is that the relationship between the independent variables and the outcome is linear. Great. You may have come across this mathematical equation such as the slope of the line. Come across that, you've worked with it, perfect. If not, just understand the concept of regression for now. So that's one algorithm that we can use. Here's an example to further clarify. Let's say we wanted to measure what effect elevation has on rainfall in New York. The outcome variable, or the variable that we really care about, right, would be the rainfall, because that's what we're measuring. And our independent variable would be the elevation. So now if we implement linear regression, the outcome variable would have to be specifically how many inches of rainfall within the New York State, as opposed to just a true or false, right? So we're not determining whether it's going to rain or not. We're actually trying to find out how much rain, right? How many inches of rainfall based on elevation. So the true-false category would simply indicate whether or not it rained at X elevation, right? But that's not what we want. And that's because our outcome variable has to be continuous, meaning that it can be any number, including fractions, in a range of numbers. So here on chart, you can see all these data points in red being input on that part, and then you have the regression, a linear relationship between the elevation. Perfect. The next type of algorithm that we can use within machine learning is logistic regression. So here, what if the outcome variable is categorical? In other words, it's not continuous. So if you have an outcome variable that is categorical, that's where logistic regression would apply. Categorical variables are just variables that can only fall within a single category. Example would be, let's say, days of the week. So if you have a bunch of data points about things that happen on certain days of the week, for example, there's no possibility that you'll ever get a data point that could have happened sometime between Monday and Tuesday, right? So either it's Monday or it's Tuesday. There's nothing in between Monday and Tuesday, right? So it's just one single day at a time, then a week. So that's categorical. So if something happened on Monday, for example, it happened on Monday. That's it. End of story. But if we think of how our linear regression model works that we took a look at in the previous slide, how would it be possible for us to figure out a line of best fit, right? How can we actually figure out a linear relationship for something categorical? Like how can we figure out a linear relationship between days of the week if something happens? So it would be impossible. That is why logistic regression models output a probability of your data point. That's important. Keep that in mind. So the log regression or logistic regression, these models simply output a probability of our data point being in one category or the other, rather than a regular numeric value. That's why logistic regression are primarily used for classification. Either it's going to be 1 or it's going to be 0. Either it's going to be true or it's going to be false, happy or sad. So that's where, keep in mind, logistic regression would apply when you have categorical variables. Moving forward, next is the classification, which is simply the process of predicting the class of given data points. Classes are, think of them as targets, labels, or categories, right? Classification predictive modeling is simply the task of approximating a mapping function, right? So let's talk about math a little bit here, which is the function f from input variables x to discrete output variables y. It's the function of f next y. Data is here labeled, meaning it is assigned a class. For example, spam or not spam, fraud or not fraud, day or night. So the decision being modeled is to assign labels to new unlabeled pieces of data. And this can be thought of as basically a discrimination problem, right? You're modeling the differences or similarities between groups. So example of, let's say, a classification problem could be analyzing an image to determine if it contains a car or a person. The algorithms, the classification algorithms, because there are a lot of those available, okay? But it's not possible to conclude which one is superior to the other. It just depends on that scenario, the business problem, or the issue that you're facing. So it depends on the application and nature of available data set. The decision tree is a methodology, and I'm going to show you that next also, which builds the classification or regression models, right? So it can build either classification or regression models in the form of a tree structure. So essentially doing an if-then analysis, right? So it moves forward just by, asking if, then, or else. Okay, simple logic. It utilizes the if-then rule, which is mutually exclusive and exhaustive for classification. The rules are learned sequentially using the training data one at a time. So you go one step at a time. Based on the output, you go to the next step. Based on that output, you go to the next step. So each time that rule is learned, the tuples covered by the rules are removed. This process is continued on the training set until meeting a termination condition. So that's how it kind of moves forward, classification algorithms. Here's a visual example illustration of a classification. So here's the decision tree. The question is, should I accept a new job offer or not, right? So the question is, should I accept a new job offer? So notice on the trees, starting from the top and trickling down, you have the decision nodes, okay? Sort of like rectangles, right? Decision nodes. And then you have questions such as salary, if it's at least 50,000. If it's yes, the next decision node is commute more than 1 hour? If it's yes, then I'm going to decline the offer, right? So here's the termination endpoint. If, for instance, the salary is at least 50,000, starting from the top again, and then the answer is no, I'm going to decline the offer right off the bat because that's it. That's a termination point. And moving forward, if the commute is more than 1 hour, if no, then the next decision node is offers free coffee or not, right? And if it does, I'm going to accept the offer. If it doesn't, I'm going to decline the offer, right? So you get the idea, right? So you can start building the tree, decision tree, as you move forward within your machine learning problem. Here's another classification illustration example. The artificial neural network, a word that you may have heard, is simply a set of connected input-output units, where each connection has a weight associated, such as the beta weights, right, regression weights, which is to develop and test computational analogs of neurons. So think of this as, during this, let's say, learning phase, what happens is the network learns by adjusting the weights, right? So if the weight is 1, so it's going to adjust these weights at each and next step so as to be able to predict the correct class label of the input tuples. Okay. So again, not in depth, but just get an idea for now. The goal is so that you understand the classification concepts. So here you have an input layer, you have several input layers, goes through all of this mesh, right, that you see, and eventually figures out about 5 of these nodes within the hidden layer, and then the output layer, it gives you the one termination point or thing that you're looking for, which is the estimated form work, labor, quantity, man hours, right? So based on all of these different inputs, like total slab area, total length of beams, this is sort of like a construction example, okay? So all of these inputs are input into the machine learning algorithm. It goes out there, and based on your target answer, it provides a prediction or an output. Further examples, additional examples of classification problems that you'll come across, such as text categorization. Example would be spam or not spam, fraud detection, optical character recognition, machine vision, right? Face detection is pretty common these days. Natural language processing, like spoken language understanding, market segmentation, is pretty important. And bioinformatics, classify proteins according to their function. So there's several applications of classification problems in various industries that you can take a look at and apply. Good and bad classifiers, right? When do we know whether a classifier is good or bad? Well, a good classifier has sufficient data, low training error, and simple classifier. So it's easier to identify the plus and the minus signs, right? So that's a good classifier. However, you may come across a minus sign or an entity within the plus signs, right? As you can see in the top picture here, that'd be an outlier or something that happens occasionally. But typically, majority of the data is separated. Bad classifiers where you have insufficient data, small amounts of data. Remember, machine learning requires typically large data sets, okay? The larger the data sets, the better it is. Similarly, training error is too high. That's also a bad classifier. Or if the classifier is too complex, you really can't make sense of the data, right? So you can't really classify. Maybe you need to use a different type of algorithm, such as the logistic regression or clustering. Great. The next set of algorithms is clustering k-means. And by the way, I'm just covering these important ones out there. There are several others that you can take a look at also. So clustering is k-means, where you create a mean, right? The average. So data is not labeled in this case, but can be divided into groups based on similarity and other measures of natural structure in the data. Remember clustering? Great. An example would be organizing pictures by faces without names, where the human user has to assign names to groups. So here, each data point is classified simply by kind of taking a look at the distances between each of these dots from within a group center, and then classifying the point to be the group whose center is closest to it, right? So each of these clusters that you see will have a center point, and then the distance is measured from that center point to each of these small bubbles within the particular group. and then recompute the group center by taking the means of all the vectors in the group, right? So this is the mathematical algorithm that clustering k-means uses. So you can apply this as well. So in this lesson, just wanted to cover the types of various algorithms out there. If you have any questions, post in the discussion area. I'll be glad to provide additional examples, give you some additional hands-on. If you need to understand something more, I'll be happy to help. So practice with this. Hope this helps. Let's move to the next lesson.